All right, we are back. This is Calc 1. We are finally finished with the Chapter 5 note packet, and now we are looking at the test review. So we're going to go over all the problems in the test review. So here goes. I did it on pencil and paper because there's not enough room to squeeze it in there. You'd have to use a microscope. So it is page 44 and 45 in the note packet. And let's jump right in. They want us to find f of x, so do the antiderivative of that. Remember how antiderivatives work. Hopefully by this point, it's kind of second nature. So you're adding 1 to the power. So that's 3 plus 1, so that's 4. And then whatever that is becomes the reciprocal as the coefficient. So it's either over 4 or times 1/4. Plus, add 1 to that, so that's 2. There's already a 2 there, and then that's also what we divide by. And remember, that's x to the 0 power, so x 0 plus 1 is just x. And then plus c. Always plus some constant. All right, and this we should, we'll do a quick simplification on that one. So that one, you probably could have fit on the little blank that they gave you. Wasn't much work here. Okay, so that's our f of x. Now check by finding f prime of x. So now they want me to do the derivative. So when I do the derivative of this, I take the power rule and I say this times that, which is 1, and then I reduce it by 1. So that's x to the third plus 2x to the first plus 1, and then the derivative of any constant is 0, so plus 0. And then I look at that and go, oh goodness, look, that's exactly what I started with. So. All right. Let's look at number 2. Given the following integral, evaluate the definite integral. Okay. And set up the Riemann sum. Start by listing the following: the change in x, c sub I, f of c sub I, the limit as it approaches, and then use the summation formula to do that. All right. So let's do it. First things first. Number 2, we will evaluate the definite integral. And so with definite integrals, you do not need plus a constant. We are finding the area under a curve of this function on that interval from 0 to 2. So part A is do the antiderivative. That's x3 divided by 3 plus x2. And there was a 4 there, but then I divided it by 2. And then that's from 0 to 2. So let's fix this. So it's x cubed over 3 plus 2x squared from that interval. Sometimes you'll see it like with brackets like this, 0 and a 2 instead of a little line at the end. A little line at the end is fine. All right, so now what do? We do upper minus lower. All right, and so I put in 2 everywhere I see an x. So 2 cubed over 3 plus 2 times 2 squared minus, and I put a 0 in everywhere I see an x. And on the test, yes, you have to show me this. I don't want you getting in the habit always saying that's 0, because depending on what the function, when you do take the integral, the antiderivative, it doesn't always 0 out. This one did. This one does 0 out. So write it down, and then if you just want to put an arrow through it or just don't disregard it after that, that's fine. But I need that step written down. All right, so what do we have? 8/3 plus 2 times 2 is 4 times 2 is 8 over 1. And so 24/3, so 8/3 plus 24 thirds, right? Because common denominator. So we're looking at 32 thirds. As the area under the curve. All right. So now let's do part B. Is I can squeeze that over here, and then I'll erase this and do part C right there. All right. So part B, they want the change in x, that is b minus a over n, and they want c sub I, that's a plus I times the change in x, or delta x. All right. So for this specific problem, for B, the change in x is 2 minus 0 over n. So 2 minus 0 is just 2 over n, and then c sub I is going to just be those a. So remember AB, so A is 0 plus I times the change in x. So that's just 2I over n. So it was 0 plus 2I over n, but yeah. All right, so keep track of those, because now we're going to do it using the Riemann sum, letter C, with a limit as n approaches infinity, which we did in chapter 4 a few times, right? So let's see. Limit as n approaches infinity of the summation of I from 1 to n of, and now we have to go back to the original problem. So let's, I'm going to write that down over here for reference. So we had the original problem was 0 to 2x squared plus 4x dx. So this has to be, this. So we're going to put in 4I squared over n squared. That is that squared. Plus, and then 4 times that is 8I over n. And then times the change in x, or delta x. So 2 over n. Okey-dokey. Okay. So let's split it into 2 different limits, because this plus, and let's do the distributive property and split it. So we'll kind of do 2 steps in one. Infinity of n of 8 squared n squared plus So now we want to get rid of, this is considered a constant, 8 over n squared and 16 over n. Those are constants. So let's pull those kind of out in front. So I'm going to write the limit over here. So we remember, we're still working with limits, but this is going to be 8 over n squared from 1 to n of I squared. Plus, and then that's going to be 16 over n, and I goes from 1 n of just I. And now recall, we can replace I squared and I with when it's going infinitely, when the limit goes from 1 to infinity. So here comes the replacements, the substitutions. So we've got 8 over n squared, but this is 2n cubed plus 3n squared plus n all over 6. And then plus 16 over n times, and when you have I that's going from 1 to infinity, you can replace it with n squared plus n over 2. Now we still have the limit that's going on, but now we've gotten rid of the summations forever, and it's now just all algebra. We still have to look at the limits. We got to still see what's going to 0 and what's not. So this is, we can, what can we do? We can reduce here. Let me do that in a different color. That's 3, that's 4. So here, I'm going to distribute the 4 times everything, and we'll have 8n cubed plus 12n squared plus 4n over 3n squared, 3n squared, 3n squared. All right? Oh wait, that was not n squared though, that was n cubed. Oh, bother. All the way up there, n squared. I had this times this. Sorry, make those funky little 3s. And then 16, this is n squared. I left out that when I did the distributive property. Tisk. So put a squared on those and put a 3 on this little guy. Okay, sorry about that. Now, plus the 2 can cancel into the 16 8 times. And so distribute the 8, so 8n squared plus 8n over n squared, n squared. And this is all still as the limit as n approaches infinity. Okay. So now we can wipe that out. So the limit as n approaches infinity of 8/3 plus the 3 goes into there 4 times, and there's still an n left in the denominator there, plus 4 and 3 and 2 down there, plus 8 over 1, those n squareds die, plus 8 over n. Now you apply as n goes infinitely large. And so what does that mean? Well, that means this is a million, this is a billion, this is a trillion. So essentially 4 divided by a trillion, that's 0. That's really 0. 4 divided by 3 times infinity squared, 0. So anything basically with a variable in the denominator, or a variable squared in the denominator, or to the third or anything, that's going to go to 0. And then we have just this, 8/3 plus 24/3, because I got to multiply by 3 top and bottom, so I can add them up, which is 32/3, which is the super long way. It's so much easier to integrate and do upper minus lower. All right, so that was number 2, A, B, and C. Let's look at number 3. So all the rest, 3 through 8E, are just integrate. So clear the board, and we will integrate Rama. How are we doing for time? All right, number 3. Definite integral from -1 to 1 of the cube root of t minus 2t dt. So we'll do a quick rewrite. We'll call that t to the 1/3 minus 2t. And again, I've put parentheses around a lot of just dt. That kind of counts for the whole thing. You don't, it's not a requirement. I had some professor that said that's a requirement, and so I always do that. So add 1 to that, that's 3/3. That's 1, right? So t to the 4/3, and then the trick here is you just say, okay, well, it's divided by 4/3, which is the same as multiplying by the reciprocal. So that's got a 3/4 in front of it. And then add 1, so it's minus 2 over t squared, and then a 2 down there, so those 2's are going to cancel. And that's from -1 to 1, and so we have 3/4 times t to the 4/3 minus t squared from -1 to 1, and we do upper minus lower. So we do 3/4 times 1 to the 4/3. So think about that. That's 1 to the 3rd, to the 4th power. So 1 times 1 times 1 times 1 is 1. And then the cube root of 1, which is just 1. So that just shakes out to be 1. 3/4 times 1. Plus, oh, no, minus 1 squared. So 3/4 times 1 minus 1, that's the upper. Minus the lower, that's 3/4. This one we got to use the noodle a little bit here. We got -1 to the 4/3, so that's -1 to the 4th power. We do that first. That makes it +1, and we take the cube root of it, and so that becomes just 1 again. So minus 4 times 1, and then minus -1 squared. And so -1 squared is 1, so it's minus 1. So at the end of the day here, right, that's 3/4 minus 1 is -1/4. And then minus the same thing, -1/4. That's -1/4 plus 1/4, which is a big fat 0. Oh, all that just to find out it's 0. There we go. Let's look at number 4. That one we're going to have to split it up. We don't ever do quotient rule or product rule or anything like that. So we're just going to split this into 3 different fractions. You got x cubed minus 2x squared plus 1 over x squared dx, and we want to integrate, so x cubed over x squared minus 2x squared over x squared plus 1 over x squared dx, and simplify x minus 2 plus x to the -2 dx, and now do the antiderivative. Squared times 1/2 minus 2x plus, remember that's plus 1, so it's x to the -1 divided by -1. Oh, no more dx. And it's indefinite, so plus c. Plus c, plus c, plus c. And then, yeah, we can clean that up a little. This would be fine. I'd give you full credit on the test for that. That's fine. But that's easy enough to clean up. And just call it minus 1 over x plus c, right? So hopefully that one is easier for you to get your head around. Once again, number 5. So number 5, we're back to a definite integral from 0 to pi. 1 minus cosine x, quantity squared, sine x, dx. Okay, so u substitution. It was written as cosine squared u. I just, or maybe it wasn't. How was it written? No, that's exactly how it was written. Okay, that's fine. So we're going to say u is equal to 1 minus cosine u. And then du is when I do the derivative of negative cosine. That's actually sine. Derivative of 1 is 0. So we got the sine of x. Sorry, that's supposed to be x. Sine x dx. And now check it out, check it out, check it out. We got sine x dx right there. So we don't have to, this one is a lot easier than it appeared. So du. Right, we just pop that back in. Because this, when I did the derivative of that, I got exactly what was outside of the, and so we get to just replace that, do the antiderivative. That is cubed over 3 from 0 to pi. And so we are looking at 1 minus the cosine of x, quantity cubed divided by 3 from the integral from 0 to pi. And so it's upper minus lower. So 1 minus cosine pi, quantity cubed divided by 3, minus 1 minus cosine 0, quantity cubed divided by 3. And so what, the cosine of 90 degrees, right? Remember coleslaw? Not 90 degrees though, 180, sorry. 180. I said 90, jeez Louise. So this is 0 or 2 pi. So cosine of 180, the cosine of pi, is 0. So this is what we have. Wait a second. Coleslaw. No, it's not. What am I doing here? That's 1, 0. This is negative 1, 0. Good duh. So the cosine of 180 is negative 1. And then we cube that. And the cosine of 0 is 1, but that's not going to work out for that one very well. I could have pulled the 1/3 out in front too if I wanted to. I just left it underneath. All right, so there we go. So this is 2 cubed, which is 8/3, and that's 0 cubed, which is 0 divided by 3 is 0. So it's just 8/3. Here, I'll do one more line. I should do one more line. 2 cubed over 3 minus 0 cubed over 3. There we go. There you are. Well, let's look at number 6. Integrate with E. e to the 2x over e to the 2x plus 1 raised to the 4th dx. So u substitution, u is equal to e to the 2x plus 1, du is equal to 2e to the 2x dx. Now, when I look back at this, I got an e to the 2x dx. I got this. I got this. I don't got that. So I have to solve this out for that so I can replace it. So this times e to the 2x dx. That's what's going on there. And so this 1/2 du is equal to e to the 2x dx. So this equals this. I can now do my u substitution. So 1 over u to the 4th times 1/2 du. And so now, normally I'm a lot lazier, and I will be lazier even on this review, where I don't show exactly what happened there. This, I just take that and pop it out front. So I'm usually going to this step and this step. That's usually where I land. I usually don't have this line in there for you. Pidoki artichoke. All right, let's integrate it. So we got 1/2 times, add 1, so that's u negative 3 divided by negative 3. And plus c. And now remember, don't stop there. We gotta substitute that u back in. So now we got this. We got 1/2 times negative 1/3 times, and instead of u, we have e to the 2x plus 1 raised to the negative 3rd power plus c. Right? And so what is that going to look like? Let's clean it up. It's negative 1 over 6 e to the 2x plus 1 cubed in the denominator plus c. All right, lovely. Now, if you left it like this, I'd still give you credit. This is fine. Although you should really have 1/6. You should have at least negative 1/6. But if you had negative 1/6 times this, we're good. All right. Let's look at 7. So number 7, we have interesting. So what are we going to do here? Oh yeah, this is kind of a pre-cooked one. So look. So let's say u is equal to the innermost thing here, the x cubed plus 5, yeah? And now look at what happens. I do du dx, and the dx is going to be moved over here. So 3x squared dx. But now I look and go, ooh, I got an x squared dx. I don't got a 3, but I got an x squared dx. So they kind of pre-cooked this problem for me. I got that part. This part is easy to fix. I just divide the 3 and I say 1/3 du is equal to x squared dx. And now I can substitute that in. And so that 1/3, I'm going to pull that all the way out front. And I got u to the half. And I got du. And now I do the integral. So add 2/2, right? Again, there's kind of a shortcut that you can do it in your head. Instead of adding 2/2 like this, you say this plus that. That's u to the 3/2, and then whatever's there, you multiply the reciprocal out front. Get that 1/3 still hanging out front there. And then, let's see. And so, I mean, that would be fine. 2/9 would be better. But you can't leave a u. We got to put in the x. So there's no u in that original problem, so you got to put an x in there. So 2/9 x cubed plus 5 to the 3/2 plus c. So a lot of times you can simplify this, multiply top of it, get the 2/9, and put the u substitution back to x's in the same kind of step. Save a little paper, a little time. All right, lovely, lovely. Let's look at 8. Oof, this is getting harder to erase. I'm gonna have to bust open a new marker. New black marker. Oh, oh. Pack. I must have used it. Come on, package. There it is. Okay, number 8. We have secant 3x. Oh boy. 1 plus tan squared 3x dx. Yoinks. 4th degree. We don't work with 4th degrees. Here. Oh, I see. Let's use the Pythagorean identity. Pi here. So remember, sine squared plus cosine squared equals 1. But if you divide everything by cosine squared, so this by cosine squared, this by cosine squared, this by cosine squared, that sine over cosine is tangent, so that's tangent squared. And then that's 1, and then that's secant squared. Aha! And that's what we have right there. So let's first substitute this for secant squared of 3x dx. And this is secant for 3x. And so now we can cancel those two. So we're just looking that, which is in our wheelhouse, right? So now we still do a u substitution. U is equal to 3x, du is equal to 3 dx. We don't have a 3 there, so we're divided by 3. So 1/3 du is equal to dx. So now we can substitute in and say this is 1/3 secant squared u du, and then the antiderivative. What would I take the derivative of what to get secant squared? That of course is tangent, right? We got the 1/3 still there. We got a little plus c here. Don't stop there. Remember what we did. We got to put that 3x back in. So we got 1/3 tangent of 3x plus c. Lovely. Let's look at number 9. Oh no, not number 9. Number 8b and 8c and 8d, 8e. I got stuck up on 8 apparently. Okay, there's let's go to 8b. So we have the integral of e to the 7x plus 1 dx. All right, so u substitution, u is equal to 7x plus 1. Du is equal to 7 dx. There is not a 7 here, there's just a dx. So I got the 7, 1/7 du is equal to dx. Sub it back in. We got 1/7 e to the u du. 1/7, the derivative of e to the x is e to the x, so the antiderivative of e to the x is e to the x. And don't forget to sub the 7x plus 1 back in. That you really should have a parenthesis on it. You shouldn't just say e to the 7x plus 1. You should have a parenthesis. Power. All right. Yeah, I'm going to increase the board for you. So let's look at 8c. 8c. 3, I see. So here comes 8c. We have the integral of x over x squared plus 1 dx. So u is equal to x squared plus 1. Du is equal to 2x dx. We've got to fix it because it's just a dx. Well, no, there's an x dx. Remember, this is really 1 over x squared plus 1, and this is x dx. So I have that, but this 2 is a hanger-on, so divide it out. And so that's kind of the fix. I have to put a 1/2 over u, and x dx is just du now. And now, SpaghettiOs. How do I do that? I can't say u to the negative 1, because then when I do u to the negative 1 and add 1, I get 0. And it isn't it. So this is that special, right? When I take the derivative of the natural log, I get 1 over x, the natural log of x, the derivative of the natural log of x, 1 over x. So the antiderivative is ln of the absolute value of u plus c. And 1/2 ln, remember to get the x's back in there, x squared plus 1. Now, in some books I've seen it where they're like, okay, you don't need the absolute value anymore because anything that you're going to square is going to end up positive and you're adding 1, so it's always going to be a positive anyway. But we didn't do it. You can just leave it like that. All right, 8D. Next. We have tan x dx. All right, I guess you'd say u is equal to x and du is equal to dx. I would be okay if you didn't do the u substitution for this. Tan u du, and that one would be, look that up. So it's the opposite of ln cosine x. Absolute value of cosine x. That one's just, you don't have to have that memorized. If that's going to be on the test, they'll give you the form. All right. 8E. 8E. Let's look at 8E. Yeah, that one. You need the whole board. To pi over 6, so 30 degrees, cosine of 2x dx. All right, so we're going to say u is equal to 2x, du is equal to 2 dx. There's not a 2 out there, so divide out the 2, so 1/2 du is equal to dx. So we got 1/2, and the definite integral from 0 to pi over 6. of the cosine of u du. And then remember, it's the antiderivative. So I take the derivative of sine to get cosine. Derivative sine u. Got 1/2. I'm going from 0 to 30 degrees. All right. Don't forget to put the 2x back in there. That's kind of important because that's going to change up what we're actually taking the sine of, right? Over 6. So it's upper minus lower. So I've got 1/2 times the sine of 2 times pi over 6. So the 2 in the, it's pi over 3. And then minus 1/2 times the sine of 2 times 0, which is 0. Okey-dokey. So pi over... Oh, wait a second. That wasn't pi over 6, it's pi over 4. Doggone it. Sorry, my eyes are old. It's important to write down the problem that they asked you to do. Okay, so when I put in pi over 4, the 2 cancels into the 4, I get pi over 2, so 90 degrees. So they want the sine of 90 degrees. You can do this pi over 2, which is 0, 1, coleslaw, so sine is 1. So that's 1 times 1/2 minus, and the sine of 0 is 0. So it's just 1/2. That is our integral. Alrighty dighty. So that was page 44. Let's do page 45 and we're done. 45 and we're done. Look at number 9. Okay. Nice. So, okay, they didn't give me the function, they gave me the answer. So they said from 2 to 5 of f of x dx, that's equal to 5. And from 4 to 5 f of x dx, that's -3. All right. So the first one, they want to know what's happening from 5 to 5 f of x dx. Anytime that number matches that number, it's big fat 0. How about 5 to 4? 3 times f of x dx. Again, when they switch the interval, if I switch up the 5 and the 4, then it just makes it a negative. So this is the same as this. The opposite of, I can pull that 3 out, of 4 to 5. So if I put a negative in there, I can switch that around. So since they haven't switched around, I put a negative, I can switch it back. And now I just have -3 times -3, which is +9. And then C. What did they do with C? They want it from 2 to 4. You might say, uh-oh, we don't have 2 to 4. We don't have 2 to 4, but we do have 2 to 5. And then we have 4 to 5. So if I took this whole interval, but then I subtracted off this little piece, it would be 2 to 4. So I could do that. So I'm really just going to take this one minus that one. So two to 5 f of x dx minus 4 to 5 f of x dx results in 2 to 4 f of x dx. So that is just 5 minus negative 3, which is 5 plus 3, which is 8. Okie dokie. So that was a quick review of those rules. All right, look at this. A little real life problem. A particle moves with acceleration given by a of t equals 2t minus 4 and has a velocity of 2 meters per second at time 1. Find the velocity function. Nice. All right. So we have S, and then we have V, and then we have A. Remember? S, the particle moving, then if I take the derivative of that, I get velocity. If I take the derivative of velocity, I get acceleration. They gave me acceleration, asked for velocity, so I'm going to integrate. If I integrate, that's going up. If I derivative, that's going down. All right? So let's do the integral. Velocity v of t is going to equal the derivative of a of t dt. So what does that mean? That means I am going to integrate. This is number 2. I'm going to integrate. What did they tell me the acceleration was? 2t minus 4. All right. So add 1, t squared, 2, divided by the power, minus t plus c. That's why it was important that they gave us, because we're going to find the general solution right now. Oh, here's your dad joke for this note cycle. What does a general put in his sleeveys? What does a general put in his sleeveys? His armies. Okay, so we have that. That is the general solution. We want the particular solution. Which means we need C not to be just a letter, we need that to be a number. And we couldn't find that unless they gave us more information, which they did. They said the velocity is 2 meters per second at t equals 1. So I know this is big fat 2, and this is big fat 1. Now I could go back to my sweet algebra skills and solve for t carefully. So 5. And so the particular solution is v of t, velocity function, is t squared minus 4t plus 5. That is called the particular solution. But we needed the point in order to do that. We needed 1 comma 2, otherwise we couldn't do that. All right. Let's look at 11. 11 is just integrate, and then 12 is so much fun. And the area under the curve geometrically, draw the graph and explain if the integration represents the actual area. If I were taking a test, specifically test 3, I would definitely pay attention to number 12 when I work it out here. Hint. All right? All right. So let's look at 11, A, B, C, D, all that junk. Okay, so that's what we just did in 7, I think. So here goes. Physics, well, physics fun. All right, so here's the interesting one we're going to use here. That formula. Don't have to have that memorized if you're going to do it on the test, but we'll give it to you. Yeah. Okay, let's. A is 7. U is 3 minus x squared. Oof. So du is going to require us to do back to chapter 3. So first you do the power rule, but then you multiply by the derivative of what's inside there, and then the dx after that, right? And so that negative will just crank it onto the 2. So I got du is equal to negative 2, 3 times quantity 3 minus x dx. Now, when I look back up here, they gave me a 3 minus x dx. I got that. And I got this as my u, that whole thing as my u. But I am missing the negative 2. So I gotta solve it. So I got negative 1/2 du is equal to 3 minus x dx. I have 3 minus x dx there. It's right here. It's 7 to the 3 minus x squared 3 minus x dx. So see, I've got that, and I've got that, and so I just put in my negative 1/2 right there, and I put in my u right there, and that negative 1/2 I'm going to crank out front. And I got the squared already on the u, so it's just 7 to the u. And then du. Okie dokie. So now differentiate, and so that's just going to be that thing. So negative 1/2 times 1 over ln a times a to the u plus c. That's all multiplied, so I didn't really need a separate thing. So, and then put in your originals back. So negative 1 over 2 ln a we said was 7, so the natural log of 7 times 7 to the 3 minus x squared, and then plus c. So it looks like a really awful answer, but really at the end of the day, we were just subbing everything back from that formula. So, all right, let's look at B. 3 to the 2x. Let's see what tomfoolery got up to with 11b. Okay, so u is going to be 1 plus 3 to the 2x. Oof. So du is going to be ln 3 times is 3 to the 2x times the derivative of the power, which is 2 dx. Yoinks. And then I look back at what I have. They gave me a 3 to the 2x dx. And I got a 3 to the 2x dx, but I got this other extra junk. So 2 ln 3, and then times 3 2x dx. So I got that, but that means that's gotta go. So I got 1 over 2 ln 3 du, and that's equivalent to my 3 to the 2x dx. Okay. All right, so now we just sewed in. We've got this out front, 2 times ln 3, 1 over 2 times ln 3, the integral of 1 over u du. And then when I do the antiderivative of that, that's ln. So I got 1 over 2 ln 3 times ln u. I think I need absolute values on that. Yeah. Plus c. And then don't forget to put in your backfill that 2, 3 ln 1 plus 3 to the 2x plus c. Whew. 11 c, d, and e, huh? And then 12. All right. Let's press on, integrate. What's going on with this? So let's rewrite it. 4 over 1 squared plus 3x squared dx. So we're going to use the arctan formula. So what does that look like here? I'll put it over here. That is du over a squared plus u squared is equal to 1 over a arctan of u over a plus c. That's the formula we're using. So we got that 4. Let's ship that out front. Okay, so what do we got? We got a is equal to 1. We got u is equal to 3x. We got du is equal to 3 dx. I don't have a 3 dx. I got a 4 dx. That doesn't help me. So I gotta solve it for dx. 1/3 du equals dx. All right, so now I could take and insert that in. So I got the 4 already out there, 4 over 1. It's 1 over 3. It's 1 over all my stuff here. A. Yeah. A. A squared plus u squared. Du. Good boy. My brain just froze up there for just a second. All right, so now we're going to take that and junk it in there after we do this. So write that out. So what do we got? 4/3 times 1 over, and let's just put the numbers in there. A is 1, arctan, u is 3x over 1, and then plus c. Okay. And then don't leave it 1 over 1. 4/3 arctan of 3x. Let's see. And yeah, we should put parentheses on that so we know it's not the tan 3 times x. All right. Lovely. 11c. Let's do 11d. Let's do a quick rewrite. We'll throw the 3 out in front of there. 1 over 2 square roots of x times quantity 1 squared plus the square root of x squared dx. Now, the reason we're doing that is the square root of x squared is because we want it squared and squared because we're using which formula are we using? The arctangent formula again. Oh, did I reset already? There. Okay, so here we're using our tangent formula. So we want this. What do we got for our tan formula? du over a squared plus u squared equals 1 over a arctan over a plus c. So we want to use that. So I had to make this look like that. Kinda. So here, let's see what happens. We got a is equal to 1. We got u is equal to the x to the 1/2. So we got du is equal to 1/2 x to the negative 1/2 dx, which is du is equal to, what is that, 1 over 2 square roots of x dx. And see, that's why we left it like that. See, that's why we left it like that. Because look, we got 1 over the, we got that. You see it? So look, if I just rearrange this a little tiny bit, I'll put the 3, I'll put that there, I'll put 1 over 1 squared. Oh, here, we're going to even put it in parentheses. It'll look just like this in a second. 1 squared plus the square root of x squared. All right, and then times 1 over 2 square roots of x dx. Voila. So that's just a big fat du. And this is just a 1 over a squared plus u squared. And this is just a 3. And then I just put back in my a and my u. So let's do that. So we end up with 3 arctan. Oh wait, I didn't integrate. Gotta integrate. So we got the 3 arctan of u over a plus c. Now we can put back in the u. So 3 arctan of the square root of x over 1, which is just the square root of x, plus c. So that looked like they kind of wrecked the whole thing, but that really kind of saved us. So we didn't have to solve anything weird or anything. All right, it was still a hard problem. Let's look at D11E, 11E, 11E, 11E. 11E, 11E, 11E. We're going to use du over u square root of u squared minus a squared equals 1 over a arc secant of the absolute value of u over a plus c. That's what we're using for this one. Let's do it. We got x over squared square root x squared squared minus 2 squared dx. All right, so instead of x to the fourth, I wrote x squared squared. Instead of 4, I wrote 2 squared. I think everything else is the same. Okay, so a is equal to 2. U is equal to x squared. Du is equal to 2x dx. I don't have a x dx, so they weren't as nice on this one. So 1/2 du is equal to x dx. So I gotta put a 1/2 out there. So I got 1/2 times integral 1 over x squared I don't need that. Hold on. I got it ready to go, right? Yeah, I'm ready to go. Let's go. This is just u. And then the square root of u squared minus a squared du. Righto? Righto. So then integrate that. So we got 1/2 times 1 over 2, so another 1/2, arc secant, u, absolute value of x squared over a 2, and then plus. And so we can make it 1/4. 1/4 arc secant of, and again, leave the absolute value on there, but in the future, it's x squared. It's going to be positive. That forces a positive no matter what. All right, on to number 12. Ready for time. Oh no, we're over an hour. All right, number 12, number 12, number 12. And then we're done. The review for the test. Test 3, chapter 5. So they want us to explain what is happening here. 12, they said do it geometrically, do it with the integral, and tell me what you get on both of them. And then explain why there might be different. So let's see. Let's graph. This is the line. Remember, y equals negative 1x plus 3. The slope is negative 1 over 1. The starting point is 3. On the y-axis, I go up to 3. Y-intercept, down 1 over 1. Down 1 over 1. Down 1 over 1. Down 1 over 1. They want it on the interval from 0 to 4. Inclusive. So they want this area and this area. So if we were doing this geometrically, I said find the area. You'd say, okay, that's 3, that's 3, that's 1, that's 1. Area of a triangle is 1/2 base times height. So you would say this. You would say 1/2 times 3 times 3 plus 1/2 times 1 plus 1 And that would be 9/2 plus 1/2, which is 10/2, which is 5. And that would be the area. We'd say, okay, if we were going to integrate from 0 to 4, the definite integral from 0 to 4 of negative x plus 3 dx, what we would do is we would say, all right, let's do the antiderivative. That is add 1, so x squared, and then divide that by 2. There's still the negative there, plus 3x from 0 to 4. And then you'd say upper minus lower. And so then you would say, okay, I'm going to do the opposite of 4 squared over 2 plus 3 times 4 minus the opposite of 0 squared divided by 2 plus 3 times 0. So that whole thing is 0. So this is, what is that, 16 negative 16 halves plus 12. That is negative 8 plus 12. Negative 8 plus 12, which is 4. And then you go, oh no! What happened? Why was this 5 and why was that 4? I thought we were finding the area under the curve. We are finding the area under the curve, but when you integrate, anything above the x-axis in integration counts as positive, and anything below the x-axis counts as negative. So when we worked it out as a geometry problem, you just found the total area, not concerned about whether it was above or below the x-axis. When you integrated it, it matters if it's above or below the x-axis, and so you ended up with 4 because you took this 9/2 minus 1/2 and got 8/2, which is 4. I mean, we did it through integration, but that's why that's 4 and that's 5. So the reason the answers differ is because when using integration, any area below the x-axis is considered negative. The reason we ended up with different answers is because when integrating, anything below the x-axis is negative. Okay. All right, lovely. Okay, I'm now going to play Flipbook. I'm going to go through the entire packet, one page at a time, so you can double check your work against mine. That's just the page where I mark off as I go. So let's take a look. Page 2 is right there. And again, you could just freeze frame it if you need to copy anything. Page 3. Page 4. That's a lot of stuff. Page 5. Page 6. Page 7. 8. Page 9. Page 10. Page 11. Page 12. Page 13. Page 14. Page 15. Page 16. Page 17. Page 18. Page 19. Page 20. Page 21. Oh, look, I even said on the test, right to 0. Page 21. Page 22. Page 23. Oh, that's a little scribbly. I don't need that. $272. That's supposed to be 272 15ths. Sloppy handwriting made it a 275. Page 24. Ooh, those are the ones that you need to know how to do. Those circled ones. Page 25. Lots of writing there. Oof, my penmanship teacher is rolling in her grave. Page 26. Page 27. Page 28. Page 29. Page 30. Page 31. Page 32. Page 33. Page 34. Page 35. Page 36. Page 37. Now, page 38 doesn't have anything written on it. Oh, and this, we didn't cover these officially, but you can look at them if you want to. Page 39. 40. Page 41. That's more of a Calc 2 kind of worry. Page 42. So you don't have to copy those down, the 5/8. And then 43 is just the stuff, right? Differential rules. I'll put that on the test for you. And then the review, 44. So you can see the original problems, 44, 45. And then 46 is the key. And then I'll show you the handwritten ones that I did. There's 8 pages of those. So this is just the same problems, just handwritten out. Page 1. Page 2. Page 3. Page 4. Page 5. Page 6. Page 7. And page 8, which is going to be on the test. This one, or one like this. Not this one, but one like it. All right. And that is that. Chapter 5. Study, study, study.